In today's tough marketplace, we are working hard to be the industry leader in the transportation field. We want to be the best by providing our customers with fast, low-cost, quality service. And we're getting the job done. We're doing it by adapting to changing conditions in the marketplace. We're doing it with new ideas, like our QSN trains, and new equipment, like our double-stack container cars and our lightweight intermodal cars. We're doing it by getting our trains over the road safely, smoothly, and on time. We're doing it by creating training programs like the one you are attending today. This is all part of Santa Fe's traditional commitment to excellence. The professional engineer, training for tomorrow. As an engineer, you play a key role in making sure Santa Fe stays on top. It's your responsibility to maintain our schedules and provide our most important product, service. If we're going to continue to strive to be the best, we've got to make sure we operate these trains in the best possible way. And that's why you're here today, to participate in a program to help you sharpen and update your train handling skills. As you operate your trains, there are various forces at work, like gravity and resistance. These forces, also known as dynamic forces or in-train forces, are produced as locomotives and cars interact with each other and with the track structure. In-train forces must be controlled for our trains to operate safely. In order to control the in-train forces, you should have a good understanding of what they are and how they develop during train operation. Then you can apply this knowledge as you plan your trip and operate your train. As an engineer, you have felt in-train forces, and you know a lot about train handling. No doubt, some of the subjects of this program will sound familiar. So we all share the same common understanding of the subject matter. Let's define some of the more important terms and basic train handling concepts. Tractive effort is the pulling force created by the locomotive. The amount of tractive effort is measured in thousands of pounds. Draft force is the tension or stretching force exerted on the draft rigging caused by the tractive effort of the locomotive. Draft force is also created by the runout of slack. The standard knuckle can withstand approximately 250,000 pounds of draft force without breaking. When draft forces exceed this amount, a break-in too is likely to occur. When starting a train, tractive effort continues to build until the consist is moving. A key point to remember is that tractive effort decreases as speed increases. Let's visualize the buildup of draft forces when you start a train. Watch the load meter. It will indicate the buildup of draft forces in your train. You'll note that the initial buildup of draft force, indicated by your load meter, occurs right behind the locomotive consist. As the train begins to move and speed increases, tractive effort will decrease. When the throttle is used properly, the buildup of tractive effort will disperse throughout your train. A rapid increase of the throttle will cause a sudden surge of tractive effort. This sudden buildup of tractive effort will likely cause your train to separate. Buff force is a force that occurs when the draft rigging compresses. We also measure buff forces in thousands of pounds. The standard knuckle can withstand approximately 240,000 pounds of buff force. Your train will derail when excessive buff forces push the wheels over the rail or cause the rail to turn over. Retarding force is a braking or holding force. Retarding forces are created by the use of the dynamic brake and the independent brake. The amount of retarding force created by dynamic braking varies according to speed. As amperage builds, the retarding forces within the train increase the buff forces. Finally, let's talk about lateral and vertical forces. Lateral forces are developed at the wheels and wheel flanges of the locomotives and cars as they push against the rail. Vertical forces are caused by the weight of the locomotives and cars on top of the rail. When the lateral forces exceed the vertical forces, the wheels will either climb over the rail, spread the rails, or even roll the rail over. This problem can occur when a change in slack is too heavy or too sudden. We've covered quite a bit, so you may want to ask a question or review some of this material before we begin a more detailed look at train handling.